Hi everyone, welcome back. On today's lecture, we are going to see about the induction type directional power relay. So, this type of relay operate when the power in the circuit flows in a specific direction. So, it is an directional relay. If the fault current is flows in a particular direction, the relay will operate. So, either forward or reverse, but not both. If it is non-directional, the fault current may go any of the direction. So the relay will identify and it will operate. But the directional relay, if the fault is occurred, the current will flow through the specified direction so that only the directional relay comes to operate. So unlike a non-directional overcurrent relay, a directional power relay is so designed that is obtained its operating torque by the interaction of magnetic field, which is derived from both voltage and current source of the circuit. So this type of relay, which is essentially a watt meter and direction of the torque which is to be set up. Okay, so it depends on the direction of current relative to the voltage which is associated with the component. So this is the schematic diagram. So here it contains two electromagnet. One is nothing but an upper electromagnet and the second one is lower electromagnet. The upper electromagnet, it carries a coil. So here we are getting the power supply from the potential transformer, that is nothing but an voltage supply. And for the lower electromagnet, we are getting the power supply from the current transformer, nothing but current. So it has a two electromagnet, one is upper, another one is lower. The upper electromagnet is from the potential transformer and the lower electromagnet is from the current transformer. So the upper electromagnet, it carries coil, and the lower electromagnet also it carries a coil. So in between the two upper and lower electromagnet, that is an aluminum disc. Okay, so because of this aluminum disc, it is free to rotate because of less weight. So here the voltage is applied to the potential coil. So the potential coil is getting energization and it produces electromagnetic flux. The produced electromagnetic flux, it moves downwards. Similarly, from current transformer, the current will be delivered to the current coil. The current coil is getting energization and it produces some amount of flux. It moves upwards. So the one flux is coming out from the upper to lower, another one is lower to upper. So the two fluxes, it will be interacting on the aluminum disc. So because of this interaction of these two fluxes, there is a force, there is a torque which you are induced in the aluminum disc. So the aluminum disc gets rotated. So if the aluminum disc is try to rotate, the two contact of fixed contact and moving contact gets touched. So because of this contact touching of two contact, okay, now we can able to trip the circuit breaker so that we can able to disconnect the faulty section from the section. Okay, so this is nothing but N type. So here the aluminum disc is made up of aluminum because of less weight, so that when it is free to rotate and it will be connected with the pivotal jewel bearing for the smooth operations. The upper electromagnet, it carries a winding is called potential coil, or it may be an voltage coil, or it may be a pressure coil, etc. And the lower electromagnet is a separate winding which are connected across the CT, and with the help of number of tappings and plug setting multiplier, so which are connected in order to change the number of tappings and plug setting multiplier to adjust the voltage and the current value. So the interaction of these two fluxes across the aluminum disc, so there is a driving torque. So the driving torque which is greater than the retaining torque, it is because retaining torque. The retaining torque is produced by the spring. So once the driving torque is greater than the such, it turn away and moving contact so that the fixed contact. Consequently, the relay remains inoperative. However, the reversal of current in the power universe direction in the disk. So there is an assessment. Differential relay use the principle of time domain comparison, frequency domain comparison, current magnitude comparison between a incoming signal and monitoring the power factor. So put your answer in the comments section. And these are the few reference books. Thank you.